Hello guys, I'm MD Nazmul, and I'm going to show you a gallium nitride based Doherty amplifier that I designed. Well, I'm not going to show you the entire layout from the beginning because it takes a lot of time to complete a single layout of an IC, because it involves design rules checking or DRC and also the physical verification or LVS. So the completion of the entire layout is very lengthy, and it's impossible to cover in one single video. And therefore the purpose of this video is just to give you an overview how a GaN IC process looks like when you make a layout in it. So this is a process, a GaN HEMT IC process. It's a commercial 250 nanometer GaN HEMT IC process. And this process has two metal layers, metal 1 and metal 2. We can check it from the substrate settings. So let's open it. So as you can see, metal 1 and metal 2, they're connected by via 2. So it's a very simple IC process, because most of the CMOS IC processors, they've got 9, 10 or 11, 12 layers. So compared to the CMOS process, the complexity of the GaN IC process is very low. Well, the preference of GaN IC process it can be found in high power application, because they can deal with very high power. The drain voltage is very high compared to the CMOS processes, because CMOS devices, they have very low breakdown voltage, whereas the GaN devices or GaN HEMT transistors, they have higher breakdown voltage, and the higher VDD means usually higher power, right? Anyway, so this is the layout. The dimension of the layout can be in the order of a few micrometers. I think it's 1.2 by 1.5 micrometer, square micrometer. Anyway, so you can see a couple of transistors at the center. They're basically the main PA and the auxiliary PA of the Doherty amplifier. When the main PA gets saturated and the auxiliary PA turns on, then the load modulation of the Doherty amplifier happens, right? Usually the Doherty amplifier is very high efficient amplifier, especially in the output backup power region. And normally the class A, B or normal PA, they are efficient at the saturated power. I mean, they can deliver the high efficiency at the maximum power, but not in the backup power region. But Doherty is quite opposite, and that's why Doherty is very popular in base station application and also mobile handsets applications, because most of the time our devices operate in the output backup power region, not in the maximum power region. And that's why Doherty is very important. Actually, Doherty amplifier was invented back in 1940s, and it didn't get that much attention because we didn't have the application. But with the advent of high-power devices like gallium arsenide and gallium nitride, the interest in Doherty amplifier grew again. And another reason is the modern communication standards. They use high PA signals. And high PA means, the peak average power ratio is very high. And Doherty is very much suitable in amplifying high PA signals. That's why there is so much interest in designing Doherty amplifier. And Doherty is very important in 5G applications too, because 5G will be implemented in mostly millimeter wave frequency. And I've seen papers of millimeter wave Doherty recently. And obviously, Doherty has a lot of potential in the application of 5G, no doubt at all. Anyway, so this Doherty that I designed, it operates at 3.8 gigahertz, and the efficiency is basically at the 7 dB output power backup. The efficiency is almost 62%, and the PSAT is 39 dBm. And anyway, so this IC of the Doherty amplifier only takes an area of a few micrometers, so it's impossible to discern the individual elements of the IC in naked eye. We always use microscope to measure an IC on the probe station, and by the help of microscope we can see the real view of the IC. And I have another video which shows how to measure an IC on probe station by using microscope and RF and DC probes. So this is the fabricated real IC of the Doherty amplifier that I just showed a moment ago, and we fabricated it using a commercial foundry, and this is a micrograph taken directly from the microscope when I was measuring the Doherty amplifier. So the IC world is kind of very interesting because we always deal with the microscopic world, and the world is very, very different from the world we live in. There is so much parasitic inductance and capacitance. If the frequency gets higher, the whole response of the IC changes because of that parasitic inductance and capacitance. Well, the purpose of this video was to give you an introduction to the Doherty layout, not to show you the entire layout procedure from beginning, because it's impossible to cover the entire layout in a single video. But anyway, if you have any question or comment, you can post it below. And thank you very much for watching this video. Don't forget to like it and subscribe to my YouTube channel. Thanks.